Let's look at the next sentence here. What did you write when you have 1 ppm chlorine by mass? What did you write here? Essentially 1 gram of chlorine per million grams of what?
Water.
Yeah. In this case, we'll be a little more just cool water. And so if we write it in this form, we can go from grams of cool water and convert that into grams of pure chlorine. So grams of cool water. So depends. If we had 2 million grams of cool water, we'd need 2 grams of chlorine. So just a simple ratio like that. Or 1 million grams of cool water per 1 gram of pure chlorine. And so this takes us from grams of pure chlorine to grams of cool water. So let's say I had 4 grams of pure chlorine. How much pool water could I treat with 4 grams of pure chlorine? 4 million. Yeah. Grams of pool water. So that's it. And then let's move on to the next sentence. So what do you see next here? Assume densities of 1.10 grams per milliliter for the chlorine solution. So the density, we'll just write d, little d, or capital D. And so this will be density of the chlorinating solution. The density of the chlorinating solution is 1.10 grams per milliliter. But we need to, because this is an advanced problem, for an advanced problem we need to be very specific in how we label the units. And so normally we don't leave it like this because it's not clear what it's connected to. And so sometimes we'll write it like this, 1.0 grams, 1.10 grams per milliliter. And we'll write chlorinating solution on the outside. And so this is only valid for the chlorinating solution. The water would have a different density. So as long as we're dealing with chlorinating solution, this is okay. Or we'd write it like this, 1.10 grams of chlorinating solution for every milliliter of what? 1.10 grams of chlorinating solution for every milliliter of what? Not cool water, for every milliliter of chlorinating solution. And so it just relates to the grams to milliliters. You know, so if you had 1,000 milliliters of chlorinating solution, how much would that weigh? And so this would tell it. So this converts milliliters to grams of chlorinating solution. And so if I had 2 milliliters of chlorinating solution, how much does that weigh? Yeah, 2.20 grams would be. Or we could write it like this. For every 1 milliliter of chlorinating solution, that would weigh 1.10 grams. And so what this does is it converts grams of chlorinating solution to milliliters. So depending on which way we want to go, we can use either one of these conversion factors. The next one is the density for the swimming pool water, 1.00 grams per milliliter. We wouldn't leave it like this. We might get it mixed up. And so that's why this is an advanced problem. This is an advanced problem because there's more to keep track of. You know, and just not. So this is for the pool water. So what that means is that for every 1.00 grams of pool water, let's write H2O So we'd have a milliliter worth. And so this one would go from grams of pool water to milliliters of pool water. Or we could say that for every milliliter of pool water, we'd have a 1.00 grams worth of pool water. So this would be milliliters of pool water here. So I need to be careful. I shouldn't leave that blank. Now, whether I write a 1 here or not doesn't really make a difference here. So I can put the 1 here or I can leave it out. That's because how many sig figs are in this 1 here? Infinite. Then we have 3 sig figs here. Well, if you look at that pool water, hey, that's 1.00 grams per milliliter. So does that mean the pool water is pure water? Doesn't pure water have a density of 1.00? Yeah, it does, but these are just small amounts. So what it tells me is that there isn't that much chlorine in here, or that there aren't that many pool chemicals in the water. But still, would you drink it just based on the density? No. I mean, even small amounts of impurities can have serious health consequences. So, but anyway, the second one takes us from grams of pool water to milliliters of pool water. And so we write out these conversion factors because what we're going to do is we're going to string them together to come up with an answer in dimensional analysis. All right, so that's the information. And then the question is, what volume of the chlorine solution in liters is required to produce a chlorine level of 1 ppm in 18,000 gallon swimming pool? So if we have an 18,000 gallon swimming pool, so this would be 18,000 gallons of pool water. How many liters of chlorinating solution do we need to make this pool at 1 ppm Cl? And so what I do is this here. If we have 18,000 gallons, we start off with that 18,000 gallons. And this is 18,000 gallons of cool water. And then I try to string together a whole bunch of conversion factors to take me to where I want to go. In other words, when you look at a problem like this, it's like a jungle of numbers. And so you're kind of lost in this jungle of numbers. And so there are two ways you can get out of this jungle of numbers if you're lost in a jungle of numbers. One is you can have a map. You can map your way out, a trail, let's say. Or two, you might not have a map, and then you just got to try to figure out how to get out. And so to try to figure out how you get out is the typical way, a dimensional analysis problem is solved. And so we try different paths out of there and see which one works. But so I don't have a map, and so what I'm going to do is I'm just going to take one step at a time. And the one step at a time is like this. I could have a map. Maybe I should generate a map for this. But if you don't have a map, then it's okay. You can still save yourself and get out of the jungle. What some people do is they just give up and wait for somebody to come rescue them. But unfortunately, there's nobody that's going to come to the rescue. So you're going to have to dig yourself out. And so to dig yourself out, what we need to do is just dimensional analysis. So what we're going to do is we're going to take gallons of pool water and just try to get that to cancel. If I can get gallons or gallons of cool water to cancel. It would be better if we could get gallons of cool water to cancel. But is there something that relates gallons of cool water to something else that you saw? No. There's nothing that relates gallons of cool water to anything else. But there is something that relates gallons to, we can go from gallons to liters. This one I said you don't necessarily have to memorize. 3.785 liters per gallon. And so that cancels out gallons. Now we're left with liters or liters of cool water. It's best if we can get rid of liters of cool water, but do you remember seeing something that converts liters of cool water to something else? No. And so we could go from liters to gallons, or we can go from liters to milliliters. So go to milliliters. And then just keep going. Keep going and then try to come up with the answer for this. Let's see. So you can work with your neighbor on this particular